We're going to review perimeter and area, something that you would have learned in grade 9, by looking at a couple of quick examples that involve some compound shapes or composite shapes. So what we're going to do is we're going to look at the diagram, and we're going to use the same diagram for number 1 and 2, and then we're going to look at a different diagram for question 3 and 4. You'll notice that this is sort of set up as a multiple choice question, but we're actually going to walk through how we would solve for the area of this shape to determine which one of these formulas would be useful for you. So if I'm taking a look at this compound shape, I have a small rectangle up at the top, which I'm going to label as shape number 1. And I have a larger rectangle at the bottom that I'm going to call shape number 2. I want to look at the dimensions of my area for my top triangle or my top rectangle. So that is rectangle number 1, and it has a length of 7 and a width of 3. So the area of shape 1 would be 7 times 3, because the area of a rectangle is length times width. You can refer to the formula sheet, the same formula sheet that you would have used to write your EQAO test in grade 9 to help you figure out which formula to use for these basic shapes. So now we're going to take a look at what the area of shape number 2 would be. So we know that the length of this rectangle is 15, but what we need to find out is how high the width would be. I know that the top dimension of my smaller rectangle is 7 meters. The entire side of this shape is also 7 meters because they are both denoted by that same slash. I know that the smaller part of the smaller rectangle is 3 meters. So to find out just this portion right here, which I'm going to circle, I'm going to take 7, because that's the entire length of the side. I'm going to subtract just the top part, which is 3, and that gives me 4 meters. So the width of this rectangle is 4 meters. So then if I was trying to find the area of shape 2, it would be 15 times 4, length times width. So now when I look at my choices to find the area, I need to find one that looks at adding up my areas for a shape 1 and shape 2. So the total area of this diagram is area 1 plus area 2. So if you look over here, the only one that uses 15 times 4 is A. That also has 7 plus 3. So the formula to calculate the area of this shape is 15 times 4 plus 7 times 3. And if I wanted to calculate that, I can. So 15 times 4 is 60. 7 plus 3, or 7 times 3 is 21. And if I add those two together, I get 81. And my units are meters. And because it's area, I need to square that. So we're going to use the same diagram to take a look at number 2. So number 2 asks us to calculate the perimeter of this shape. So remember, perimeter is all of the measurements around the outside of your shape. So in order to do that, what I like to do is I like to start from one of my sides and work my way around in a clockwise manner so that I'm not missing any of my sides. Because I am adding up my sides, I can look at the sides that are given. So I have 15. I have 7, which is the entire height of this shape, plus 7, which is the height of right there. I have 3, which is this area right there. Now I need to figure out what this measurement will be right here, and I'm going to do a sort of a wavy line to denote that. I know that the entire length of my shape is 15 meters. So in order to calculate this part of my shape, I want to take my 15, which is the entire length, and subtract the part that is attached to the smaller rectangle. So I'm subtracting my 7, and that gives me 8 meters. So I'm going to add 8, and then I'm going to add my last one, which is 4. So if I'm looking here, I have 1, 2, 3, 4, 5, 6 numbers. If I look at my shape, I have 1, 2, 3, 4, 5, 6 sides, so I know that I'm correct in that calculation. But when I look down here at the bottom, none of my measurements or my formulas actually have 6 numbers in them. So what they've done is they have condensed some of my calculations. So if I look, I have 2 7s. I can write this as 2 times 7 or 7 times 2. And so that's important to note as well. So if I'm looking at my choices now, I can definitely get rid of A because A doesn't have all of my measurements. I can definitely get rid of P because that also is missing that 8. So that's gone. So for C, C is gone. I can also, when I look here, I want to look to see what's left over between B and D. I only have 2 7s. I don't have 3 7s, so I'm not going to be multiplying by my 7 by 3, so D is gone. So let's just verify that B is correct. I have 2 7s, so 7 times 2. I have a 3, I have an 8, I have a 4, and I have a 15. So yes, the formula to calculate the perimeter of the diagram up above is the formula for B, and I can go ahead and let's solve that. So I have 7 times 2 is 14. 3 plus 8 is 11, and 4 plus 15 is 19. If I add those together now, 11 plus 19 is 30, and 30 plus 14 is 44. So the perimeter of this shape is 44, and my units are meters. I don't square anything when I'm finding the perimeter of my shape. So the next example looks at a shape that might remind you of a silo. So I have a semicircle at the top. You'll notice that it's showing the full circle in this diagram, but you can think about it as shading this rectangle in here and keep it as a rectangle and a semicircle. That's going to be easier to think about our calculations for. So what I want to do is, I want to number my shapes. So I have my semicircle, which I'm going to label as shape number 1, and on my rectangle, which I'm going to label as shape number 2. So the area of my rectangle is length times width, or in our case, 10 times 6. If you did 6 times 10, that's fine. Order doesn't matter when we're multiplying. Now I have to think about the area of my semicircle. So I want to look at my formula sheet to figure out what the area of a circle is first of all, and that's pi r squared. And because I'm only using half of a circle, I want to divide that formula by 2. So then my equation will be 3.14 for pi, but I have to think about what is my value of my radius. Well, I know that the diameter of my circle is 6 centimeters because that's the entire width of this shape. And so if the diameter is 6 centimeters, the radius is half of that, so it's 3 centimeters. So when I'm plugging this value into my formula, I have 3.14 or pi times 3 squared divided by 2. So now when I'm thinking about this question, I want to now think about which one of these formulas that are given to me would correspond to what I've calculated so far. Well, they all have a 10 times 6, so that's important, but only 2 of them show my area of the circle divided by 2, so I can eliminate A and B right away. So now I need to look to see which one of these formulas will work. Well, I know that 6 is not my radius, 6 is my diameter, so I can take out C, so I'm left with D as the area of this shape right here. So let's go ahead and finish out this calculation. So I'm going to put 3.14 as pi. I can also use the pi button on my calculator, knowing that the pi button uses more decimal places than this 3.14. So your answer might be slightly different if you use your pi button on your calculator than if you would have used 3.14. Both answers would be fine, unless it specifies otherwise. You have that choice between what you're going to use. So I have 3.14. 3 squared is 3 times 3, and that gives me 9. Divide by 2. 10 times 6 is 60. So I'm going to finish this calculation over here on the side there. So I can do my 3.14 times my 9 and then divide by 2 in one step. That gives me 14.13. Add to my 60 gives me a value of 74.13. And my units in this case will be centimeters, and because it's area, then I square that. We're going to use the same shape to look at what the formula would be for perimeter. So I want to think about when I'm looking at the perimeter, especially of a composite shape, that I'm only using the dimensions around the outside of the shape. So that's really important. So when I look up at this diagram, and if I just sketch it quickly over here, I have my three-sided rectangle, and I also have on top of this my semicircle. There we go. So that's important to know. So I don't need to use all three sides of my rectangle. I just want to use the 3 dimensions of my rectangle. So I'm using the 6 at the bottom, and I'm using my 2 tens along the side. So I'm not going to look at that interior line that combines or that merges my semicircle and my rectangle. What I do need to calculate, though, is the circumference of my semicircle. So that's important because I need to know what that curved shape would be. And when I'm looking at the circumference of a circle, I can either use pi d from looking at my formula sheet, or I can use 2 pi r. So you can choose to either substitute in the value for the diameter, which is 6, or substitute in the value for the radius, which is 3. I'm going to use the first one. It's a little bit more efficient. I don't have as many things to calculate. So my formula would be, I'm going to use pi d. Now this would be the circumference of an entire circle. So in order to find the circumference of a semicircle, I want to take this expression pi d and I want to divide that by 2. And that'll give me just the curved part of my semicircle. So when I'm substituting in my values, I'm going to put in 6 in here. Plus I'm adding my 10, and my 6. So if I look over here, again, I want to think about which of these formulas is going to make sense for us. They all show the circumference of the semicircle, so they're all being divided by 2. You'll notice that some of them, though, have used 3 instead of 6, but there's no 2 in front of it. So they've used the starred version of my circumference of the semicircle. So any of the ones that have a 3 in place for the diameter, I can cross those out. So I'm left with just these 2 at the bottom here. And I know that I have 2 times 10 because I have 2 sides of my shape that are 10, but I only have one side that is 6, so I can get rid of b because b shows 6 times 2. I only have one of those dimensions, so d is the formula that you're going to use. So let's go ahead and finish this question. So I can do 3.14 times 6 divided by 2. That gives me 9.42. plus 20, 2 times 10 is 20, plus 6. And the last step would be to add all of these together to give you a final value of 35.42, and my units are centimeters. So that's just a quick recap of looking at using the formulas for area and perimeter. And I've looked at composite shapes rather than just looking at simple shapes to help you out with that.